Hi there. My name is Drew Lundeen. I am the president of Purdue Orbital. Welcome to our virtual call out. This session is being recorded after our call out. Unfortunately, we had some technical issues and weren't able to record that presentation. But we're going to go through what our club is all about, some history and future plans, as well as the process for you to join us. So our team is led by these great individuals here. So myself, Saruchi Sen, Jack Martin, and Trey Taylor are engineers. They lead technical projects. Carter Doby is our operations director, and Sayantan is our treasurer. To give you a brief understanding of us, these numbers kind of describe who we are. So we're about 80 members from the College of Aeronautical Engineering, Mechanical Engineering, Polytech, Computer Science, and more. Since the fall of 2016, we've raised over $250,000. So not only are we developing technical skills, we're also going out, writing grants, being entrepreneurs. And we're a group of doers. We've completed over 20 flight tests of vehicles, rocket vehicles, suspended launches, as well as altitude balloon flights. Our record altitude is 25,000 meters, and that was accomplished by a high altitude balloon last fall. The mission statement of our organization tells you what our core values are. So we're about fostering technical and professional skills of all of our members, getting hands-on designing, building, and testing solutions to innovative to complex problems. And specifically, we're thinking in the area of space flight and launch vehicles, so going and putting things into orbit. To simplify this, though, we want to develop our technology in these engineering projects, but most importantly, the skills and experience of our members. The technical project that we've been pursuing so far is called SIGNET. It is a capstone theoretical mission where a balloon carries a rocket into Earth's upper atmosphere, at which point it is launched, inserting a satellite into low Earth orbit. We've started in 2015 on this goal, testing rocket technology as well as high altitude balloons. And now we are working to integrate those together in our HAPSIS-1 mission, as well as building our competency creating rockets by creating an in-house built rocket called Icarus, as well as we are going to be refining our final mission, SIGNET. So the first project is HAPSIS. This project is integrating that rocket and balloon technology using commercially available components. So we're not reinventing the wheel, but we are putting these rocket and balloon technologies together in a way that is new. We use the design, build, test process to kind of gradually work on our demonstrators and build up to more and more complex missions. And a lot of the work this team does is carried out in the Bechtel Innovation Design Center, which is a maker space here on campus. This team in the past has accomplished a few hanging, so suspended launches where the rocket and launch structure are suspended, simulating an air launch. So that's HAPSIS Alpha and HAPSIS Beta. And then this team has also flown high altitude balloon flights. The picture on the right there is from our most recent high altitude balloon flight where we achieved that 25,000 meter altitude. Going forward, as I spoke about earlier, this team is looking to design a system that integrates the balloon and rocket vehicle technologies. Some key features of this project will be stability of that system. So understanding how to mitigate the aerodynamic forces on our launch structure and balloon. Also, long-range communications. We have some students who are incredibly proficient with software-defined radios, and they've been leading some of that work. And this type of operation would require us to venture out of Indiana, and so there's plenty of work to be done planning the logistics for that. Next, we have a high-altitude balloon test. Again, we want to kind of push the envelope on our altitude goals, as well as increasing payload sizes as we go, allowing us to test more of a technology in situ. Right? In flight testing provides us the most knowledge. And so that's what this team is looking to do. If you were wanting to join this team, there are 5 sub-team options for you. So flight systems, they are in charge of the actuation devices that help us cut down the vehicle, bring it back to Earth once the rocket has launched from it. They also deal with stability of our rocket and doing calculations to make sure that the rocket's launch platform is stable enough. Commercial rocketry uses those off-the-shelf components to make a rocket that can fit into this non-traditional application. Balloon infrastructure works with folks from industry as well as NASA to size balloon components and prepare for our launch operations. We have a launch structure team, so this is the making of that gondola that sits underneath the balloon to which the rocket interfaces with, and this team is very manufacturing heavy. They've recently began to manufacture their structure in composite materials, so if that is something that's interesting to you. And we have avionics, the brains behind all of this stuff. They are in charge of the flight computer that goes onto the balloon, sensing the commands from the ground and performing those actuations, whether it is launching of the rocket or deploying of the parachutes that are required throughout the mission. Our next technical project is Icarus. So Icarus works on those component technologies that we would need for the future mission. They're not so much concerned with the integration of everything together as much as they are understanding what those technologies look like. So in the past, they have successfully hot-fired a hybrid rocket engine at Zucrow Laboratories. And in some current projects work we have, they cast solid propellant as we are looking to develop a solid rocket motor in this upcoming year. So as I mentioned, the Icarus team is looking to develop a student research and developed rocket that you can see on the right there, as well as some motors to do propellant characterization on the ground and prepare us for a flight motor design. We also have a cold gas thruster control system project. This is very similar to the RCS that you might see on a SpaceX Falcon 9. Building a demonstrator and firing cold gas through nozzles to orient this demonstrator will be a key step in building our knowledge in that area. So that team that works on that cold gas demonstrator, that is the guidance, navigation, and control team. We also have a propulsion team. Those were the folks that worked on that hybrid rocket engine, and now we'll be working on a solid rocket engine development. Mechatronics, they work on the interstaging device. So our theoretical mission includes multiple stages of our rocket, and so they are working on a stage separation device that will be flown on kind of a lower, smaller scale mission. And finally, rocket optimization. This team is in charge of the airframe and the sizing of the rocket that some of these other components fit into. Next is our Pegasus team, or it is systems engineering. So systems is the glue that kind of holds all of the sub-teams together, and they own the final design. So they develop the top-down planning and design and support of these goals that we have. We, in this team, focus on making sure that any of our operations are performed safely, as well as the quality of the engineering work that we produce. And in doing all these things, they really are the facilitators of the design process. This sub-team has 3 groups within it. There's a mission design team. They work on that theoretical Signet mission, mostly using software tools to plan the orbit and trajectory. Then there is Icarus Systems and Hapsis Systems. So those teams I mentioned before, these two teams work alongside those other technical sub teams to see the success of the integration and the testing and the quality of that design. If you've never heard of systems engineering before, there is some key kind of components to their work. So they are, again, those integrators. So they make sure that the parts from launch structure fit together with the parts from commercial rocket or mechatronics with rocket optimization. They also do work to plan our operations, as well as looking to the future and help us understand what our roadmap looks like and where this technology is contributing to. And finally, in that kind of quality of our engineering work, they verify and validate system requirements through testing or inspection analysis to make sure that the components that we have designed and built are going to function to meet these higher level requirements for our missions. And systems engineering is incredibly valuable. You can take these skills that you might learn from our systems team and apply them into any industry. They are universal. The design cycles that we use are common to organizations like NASA, the ESA, JAXA, or even in private space as well. If maybe some technical work isn't exactly what you're looking for, but you want to be a part of a startup culture and running of a business, the operations team might be for you. These folks administer the organization. They look over the finances and kind of our brand as a whole. So they write grant applications, they manage our relationships with the university and commercial entities. They also will interact with the public and the larger community through social media, as well as some of our branding. Yeah, that is what you can get up to in Purdue Orbital, but why would you choose us? Well, the first thing is that we're here to enhance your technical and professional skills first and foremost. So going back to our mission statement, we are for the development of our members, and through the technical work or the administrative work, the leadership roles that we have available, you will be able to build your engineering skills as well as it's a uniquely collaborative experience. All of our teams are contributing to one final mission. And so it's common for folks across different sub-teams to communicate with each other and collaborate. This is a way to build that network. Our work is fast-paced and it's really challenging. We take concepts that are, maybe talked about in our undergraduate coursework and we apply them to the real world. We own a project from end to end. And the deadlines that we set for ourselves are ambitious because we want to keep that pace that is kind of realistic to the engineering industry. There's some new technology here that we're working on too, right? There isn't a roadmap, a handbook for how to air launch rockets. And so taking on this problem gives us an ability to deal with ambiguity, to find a pathway to an objective. We're not sitting here and taking one formula and just following the way that everyone else has done it. We're kind of doing some trailblazing. And finally, the network that we have here is pretty incredible. It's folks that are passionate about engineering, passionate about access to space. And because, like I mentioned before, we're all working towards that one mission, we kind of know each other and we see each other as being on the same team. So our folks will commonly go out into industry after they work on our team. And I know that my network, and I know so many folks who are in Purdue Orbital that are now out in the industry, and I still keep up with them today. Just another thing too, if you maybe don't have a lot of technical experience coming into this, that's totally fine. We will be planning some seminars to teach skills using engineering tools or about certain types of analysis. So, That photo was from our computer-aided manufacturing seminar from last year. And if rockets are new to you, we have an opportunity for you to build your own, going through the process of building a rocket from a kit and getting certified launching it with the AAA Rocketry Association is a valuable experience that gives you kind of an introduction to rocketry. And like I mentioned before, these are just some of the companies that our folks go off to afterwards. We can see some flashy names here: SpaceX, NASA. Our people get involved in the hardware, in the software as well, in the kind of mission planning. AI Solutions is a really exciting company that we have some former members with. And also, you don't have to stay in aerospace. The skills that you learn here will be transferable. You see some companies up there like 3M or Fiat Chrysler. So this is a uniquely valuable experience, and it'll be a great way to develop your profession. Just some information about when we meet. We typically meet Mondays and Wednesdays. Sometimes we will go beyond these hours as we approach testing, and we do the technical work in these meetings. It is more productive when we can be in the same room and collaborate. And so when you come to a meeting, you're going to be doing work. It's not just sitting around. If this sounds interesting to you, this is the process for you joining us. So we have a website that details more about our missions and the progress that we've made so far. You can learn here more about the teams and also our leadership. Then you can apply. Again, on our website, we have a questionnaire where we'll ask you some questions about your interest on the team, as well as submitting a resume. And then we will be reaching out to folks and getting them onboarded, integrated into the different project management tools that we use, and getting them on the team, getting them into our meetings as soon as possible. Just some more information. If you're a new member, we have $15 dues, which are semesterly. You can go again on our website. The executives and design leads are currently posted up there, so feel free to reach out to us. You can find us on LinkedIn or the Purdue directory. And the application will be open until September 5th. Well, I guess there's not any questions because this is just a virtual call out, but I wanted to take a moment to thank you for your attention, and I hope this sounds interesting to you. You can reach out to us on Purdue Orbital or reach out to us on LinkedIn or any of those platforms. Yeah, we hope to see you in our applications.